Hey, what's up guys, my name is Cherno and welcome to episode 6 of my Ludum Dare series where we take a look at Genesis, my first Ludum Dare game, and we see what's wrong with it and we just go through it and basically do a full code review and fix all the bugs and stuff like that. Anyway, last time we basically handled mob lighting and we actually did fix it. So we made it so that, I think the time is, pretty fast here. So like mobs actually properly, when they approach a light, they get lit up and there's no bug with that anymore, which is nice. We found some really weird code that I had written. Anyway, we found some really weird code last time that we fixed for this time, which was nice. But yeah, I mean, overall it was a pretty good episode, I thought. And so if you haven't checked it out, you're gonna want to go back and check out episode 5 because it's pretty good. Okay, now we're going to talk about what I said we would move on to next, which is more or less the mechanics of the game, and we'll kind of, I think we've pretty much covered everything there is to cover in terms of graphics. So we've got all of our screen stuff. We've got the, this is kind of, the map is like the mini map thing that isn't actually in the game. We've covered how levels get rendered and all of that stuff. We haven't covered how menus get rendered and stuff like that. I don't think that's too important. One thing I will quickly cover before we get into the rest of the game, there was this main menu, because as you can see, the main menu, including like help and about and stuff like that, this actual menu system is kind of, has the game in the background, right? So how does that work? Well, the way that works, and I actually have no idea, so I'm about to find out, but the way that works is, assuming we have some kind of, so the way that we kind of work this out is, the main class, or the game class, which is the main class, right? It has a few public static kind of fields, right? So there's one for menu, and so what happens is when we start when we start the game, we create a new main menu, and so we assign that to the menu instance, right? And because we do that, menu isn't null, and thus the menu gets actually rendered. Okay, that's why we actually see, these, Genesis and play, help, about, and all that stuff. If I was to not ever create that menu, right, we wouldn't actually ever see any text. We would still see the level, but we wouldn't be able to, as you can see, hit spacebar to play the game or anything like that because the menu is null. Okay. Now, apart from being rendered, the menu also gets updated if it's not null, and that happens in the update method. So it's pretty easy. It's not really like, a lot of people ask me, hey, how do you do game states, right? Like menu state, a game state, any other states that you might have in your game. How do you create like a state machine to deal with them? And this game doesn't actually really have a so-called state machine. I mean, it does in the sense that, the state is, hey, is there a menu? Right, but there are also different states, such as this is terrible code, by the way, so don't look at that. But in terms of that, like, level gets updated, right? What is the level that gets updated? Well, that will change. Like, for example, if the biome selection says I want level 2, then level 2 will get created, and then of course next time it comes around and does level to update, level 2 is the one that gets updated. So rather than having, especially for levels, rather than having like a state machine being like, hey, I'm in the game state, therefore I need to be rendering a level right now. In this case, in this sense, at least for levels, it's constantly rendering some kind of level and updating some kind of level, because even the menus have a level, right? Because this is a level, right? And in fact, there's a function that I noticed out of the corner of my eye earlier that's called set menu level. And if we look at that, what that actually does is plays the menu theme, like the sound, the music. It creates this test.png level, right? It sets the player to be a new player input, and then adds a bunch of so-called menu mobs. And menu mobs are just mobs that have a certain behavior and a certain sprite. Yeah, that's it. They're just a type of mob, really. There's nothing really too special about those menu mobs. I am actually curious as to why the player gets created. Because I'm assuming that doesn't actually need to happen. If we were to launch this, it's probably going to crash, isn't it? Yeah. Oh, okay, because the player has a location, and that's how we set the camera. So just instead of having to like rewrite that mechanic, I guess, to position the camera, because the camera is directly, there is no camera, right? The camera is the player's current position. So if there's no player, then we don't really have a camera. So that's why I did that, I guess. But I'm curious as to what blocks the player from actually moving the camera. I'm assuming that's the fact that the player isn't updated or something. So where does player update actually happen? Because it doesn't happen here. Okay, I guess it's a... I guess the player gets added into the level, right? Where's the player? Here's the player. Doesn't look like it. Oops. Player. Okay, yeah, no, it does. Oh, but hang on. Oh, I see why. That's interesting. Okay. So the reason the player can't move is because the player doesn't actually get added to the level. You can see it gets created here, which means that its position on the screen can be used to determine the X scroll and the Y scroll, which is basically the camera's location. So we do that. However, since we don't add the player into the level, the player never gets rendered or updated, because the level, of course, is in charge of calling the update and render method for each of its mobs, right? Or each of its entities. The fact that the player doesn't exist in that list because it never gets added means that that entity, that player, doesn't get updated at all. So it's just literally the player only gets created for the sake of having an X and Y value. That's it. And that's all we do. We read from that X and Y value to determine where it is. If my voice sounds a bit high or something, it's because I've been like singing all day. And so I'm kind of a bit higher pitched than I would be if I wasn't. So just thought I'd mention that, because I do actually, I can hear myself and I sound like, I don't know, half an octave higher than I usually do. But anyway, that aside, okay, cool. So we have that. That's how the player gets used to actually determine the level and everything like that, and determine where to position the camera for the menu level. But that's about it. I mean, it's just like any other level, okay? The fact that we get text drawing over top of it and we actually get the arrow keys to work. Yeah, so this episode, in case you haven't noticed, is going to turn into how menus work. Because it's interesting, but I get asked all the time how to create menus, right? As if it's just like some complicated thing. I mean, my opinion about that is that it's easy, and everyone knows that it's easy to create a menu, but there's just so many different ways to do it that perhaps like determining the correct way to create a menu is actually something that's a bit difficult. I mean, like, there is no real correct way. There are bad ways and there are better ways, but there's no like, this is how you should make every menu ever, because that doesn't exist, right? This is computer science. There's a billion different ways to do the same thing. Some of them are, of course, going to be inferior. Some are going to be superior. Some are going to be kind of really, 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 really good for like this, but bad for this. And that's why you have to kind of know a lot of the different ways, I guess, to make menus. For example, because you need to pick the one that fits your use case and your requirements, basically. I'm going to drink some water. But yeah. Menus. Pretty cool, huh? So, I remember when I made my first menu. It's probably for this game, actually. I don't think I made menus before that. Maybe for 3D game programming. Maybe. Or maybe for that game I made when I was like 12 or 11, actually. Anyway, let's not talk about that, because that's a different topic. Topic for another video. So, menus. So, menus... There's this package here called menu, folder called menu. This is how I like to make menus. I make a superclass called menu. This is basically like a base class, usually abstract. It doesn't really particularly matter if I mark it as abstract or not, as long as I don't actually, use this. I don't think this constructor is actually used anywhere apart from in subclasses. So really, like, if I made that protected, I'm sure that it wouldn't actually care. Like, I shouldn't get any errors. Yeah, I don't, right? Because menu is never constructed. You never make a menu. You make a type of menu. So abstract is probably a better description. But anyway, the point is, we have this menu. There's two ways to make a menu. Oh, there's another constructor. I missed that. Okay, see? Nothing. Good. We have one that takes in an input handler for some reason, one that takes in a game object, which is even bigger than an input handler. I don't know why we specifically pass an input handler here, because I'm pretty sure that our input handler is static and public. It is. No need to pass that through, but we do anyway, whatever. We've got a random, we've got a game object that we store, and potentially an input object. One of these is going to be null, obviously, depending on which constructor we use. But the main thing that we have in our menu class is an update and a render function. And that's kind of the flow for anything that is anything that you interact with or that has the capacity to change over time has to have an update method, right? So for interaction, right, we need to be able to check keyboard input and stuff like that. We need to have an update method to be able to do that. And by have it like changing over time, I mean stuff like animation, or something that basically has the capacity to change at all needs to have an update function. Okay. Some people choose to like, in the scope, I don't want this video to become like a programming guide, but like, I know that, we're in Java, we're using Java right now. We're using an object-oriented programming language. So I like to, in object-oriented programming languages, I like to take advantage of the fact that we are dealing with an OP language, right? What I mean by that is, we have this object. You can see I've got this menu hierarchy. And what I essentially have is I like, everything to do with menu. Everything to do with menu should be in the menu class, right? Like, it's very easy to just create a class that is just a data-only struct and then implement all the functionality of a menu inside the game class, for example. You can do that, right? That's basically a procedural approach to kind of programming, because you're just treating this as a struct, essentially, like a struct in C, right? So no methods, nothing like that, like a struct in C, and then basically implementing everything in like a function that is in a different class, right? It's nothing to do with really OOP. But the fact that we're in an object-oriented language means we should be grouping stuff like that in methods that are in the class. So all functionality to do with menus should be in the menu class. Makes sense, right? The reason I'm saying this, and this is probably really obvious for a lot of you, but some of you, some people I know, because I tutor people privately, I know they don't do this, right? They struggle with this. And I'm not saying my approach is correct, but I'm saying if you're using an object-oriented language, that's what, in my opinion, that is the correct way to program in an object-oriented language, right? That's why objects exist. Objects are essentially data plus functionality, okay? And they should be relative to that or relevant to that object. So you'll see that I'm also basically taking advantage of virtual methods here, because what I'm doing is I'm saying inheritance and polymorphism specifically here, because what I'm doing is I'm saying I have a menu object. Now, the concrete type of this menu object is up to the assignment, right? So in this case, for example, we assign a main menu, okay? If the main menu is a type of menu, right? So I'm using polymorphism here, because I'm saying that this menu can essentially be of many forms, one of which is a main menu. Main menu overrides the update function, so I'm using virtual functions here, virtual methods, and I'm saying that this is the functionality. This is all of the entire functionality of what a main menu does, and this is everything to do with what the main menu should visually represent on the screen. Okay, very simple. We have a menu. We have any fields that we might have that are specific to a main menu, right? Anything that's common across all menus goes into the menu superclass. But everything here is kind of specific to the main menu class. We have update for interaction and changing things over time, right? Excuse me. And then we have render for everything that needs to be presented visually. And that's kind of the structure of menus, right? It's just like any other object. It's the same kind of thing it's the same. We would be doing the same thing for, entities essentially. Like, right, we have all of the kind of things that change about an entity, and everything to do with interaction happens in the update. And then obviously what the entity presents about itself visually should be in the entity's render method. Okay. So we have all that stuff here. You can see that's how we get that genesis on the screen. I actually render the text twice. I render a base layer of black, right? That's the color black. Offset 4 pixels vertically and horizontally to create a drop shadow effect, basically. And then on top of that, I render a white text, which is why you get this drop shadow effect. If I were to comment out the white, you would see just the drop shadow, and then without the drop shadow, it would look like that, which kind of looks a bit like, it's not bad, it's still readable, but I quite like that drop shadow. And then the click to focus, you can see the click to focus actually gets rendered in the main class, I'm pretty sure, yeah. So if the input.focus is false, then we have this thing where basically for 18, or rather for like the opposite of 18, which would be 32, for 32 out of like 50 kind of cycles, the text click to focus is on the screen. And you can see that if we're in a snow level, then we set the color to black because I guess the rest of the environment is white because it's snow. But yeah, pretty cool. So that's what we get here. Obviously, if I take that away, we're gonna only get the drop shadow in this case. But anyway, that's how that works. So that's not actually part of the menu. That's actually part of the game because obviously that happens even if I'm in the game. Okay, so what else do we have here? We have, yeah. So let's talk about how the interaction of a menu works and how we switch between menus as well. So we have a timer. This is actually pretty terrible. I'm not gonna lie, because at that point I don't think I knew how to implement a key typed method properly. So there was no way for me to stop, you know, going down too fast. So I basically put a timer on saying that every time you press a button, you have to wait at least 10 update ticks. So that would be about 180 milliseconds or so. You have to wait about 180 milliseconds, so it's 1/6 of a second, before you can actually go down as well. So that's enough for you to press and let go, right? If you hold, you can see you'll go up, okay? That's it. That's what the timer's for. Because you can see that every one of these input down events essentially requires the timer to be 0. And if the timer is greater than 0, we slowly bleed it down in the update. And of course, the update runs 60 times per second. So that would be 1/6 of a second, or about 18% of a second, which is why I said 180 milliseconds. Okay. So we have, yeah, so what we do when we go down is we play the menu cycle sound. The false parameter just means whether or not we loop it. So for music, of course, we loop it set to true. For sound effects, it's not. We reset the timer to 10, so it doesn't do it again. And then finally, and of course, we limit how far we can go down and up because we only have 3 options. So we make sure that the selected, which is the index of the selected menu item, which the menu items are stored here. Yeah, we essentially, which it doesn't matter that it's stored here anyway because we set the text to that. Anyway, weird way of doing it, but sure. Okay. So this should really be, oh, okay. So we actually changed, that's the initial value, but we actually change it. Okay, I see. So we reuse the same array. So, yeah, so we basically, if the selected, this is just basically us saying that if the selected item is set to whatever it is set to. If it's unselected, it's just called play, for example. If it's selected, right, then, and then this can also be 0, it doesn't matter. But if it's selected, it has to be 0 in this case anyway. We basically surround the selected item with these arrows, which is why you can tell what's selected. Now, for the help option, if I press the spacebar or the, I think it's input dot, excuse me, I think it's input.use, which could be a number of things, but I believe, I believe that we set that to space or enter. This could be either. This is also a really interesting way of doing input. I might cover that one episode because I don't do that anymore. Like I don't do it this way anymore. Okay, anyway, so we set the game menu. Yeah, so you can see that this is how we transition between menus. It's really, really simple and it's not particularly safe. Like I wouldn't do it this way, I think, if we're running 2 instances. I wouldn't do it this way, I think, if I did it again. But basically the way that we transition between menus when we hit spacebar, for example, is we go back to the game menu and we actually set the menu to be now help menu, right? So you can see that there's a static menu and this is the menu that gets rendered and updated. So we're just changing, to put this into a more technical way or technical context, we have a pointer to a menu class or a reference to a menu class. We basically change where that pointer points to be a different menu, which means that next time it comes to update the menu, of course, instead of running the render function in one class, it's a different object, which has a different like virtual table. So it looks up the other function and it basically, we basically just switch where our menu points to. That's it. And we make it point, we construct a new menu and we have it point to the new menu. That's it. I mean, that's kind of an overly technical description of how this works, right? We switch out which menu we're using. Okay, then we have the about menu, which basically happens the same way, right? We play the menu sound, which is the menu transition, I guess, sound. We create an about menu, which you can see just displays all this text basically, and has, input.back, which is escape. Here it is. If that gets pressed, we go back to the main menu. We recreate the main menu again, and we of course switch out the game's menu reference to be now to point now to a main menu instance. And that's it. I mean, it's really, really easy. There's nothing to it. It's not particularly safe. The reason I said it's not safe is because we change the game menu and then we keep doing all this code. Like this still runs basically, which is a bit weird because that meant that this reference gets lost now and this object should get destroyed. If this was, C++ or something, this would kind of be the equivalent of deleting game menu. Right, and then reassigning it, which means that this object now just got erased from memory, which is bad because it means that when we come down here and we're like, okay, suddenly, if this is C++, for example, and we're over here, we delete the game menu object, we reassign the game menu object, we have to return immediately, because if we don't, we go down here and we're like, we try to read the value of selected, but hey, selected is of course this dot selected, and we just essentially deleted this. So that memory's been freed. It might have been already overwritten. Could potentially cause a read access violation and crash. So that's not good. Obviously this is Java. So unless the garbage collector decides to delete this main menu object immediately then and there, which is never going to happen, this is kind of acceptable, but it's still kind of not, right? I mean, you could fix that by just having a return, but by trashing our own reference, because you have to realize, like, this isn't exactly reference counting, so it's not that dangerous. Because if this was reference counting, then by doing this, we would be deleting the instance of the old instance, which would actually result in being the same as delete this. But by doing something like this, we're basically deleting ourselves from within ourselves. So it is like writing delete this in a sense. And delete this is actually an acceptable thing to do, right? I mean, in like C++, it's acceptable. It's kind of like a go-to, right? A go-to is something that you shouldn't do unless you know what you're doing. And unfortunately, a lot of people always say stuff like, don't ever write a go-to. That's rubbish. I hate it when people say, don't do this. Don't use a language feature that was built into the language. Like, some features, like go-tos, require caution and require you to actually know what you're doing and be very, very careful around it. Because yes, go-tos can be dangerous and they can lead to bugs that you might not expect. But if you know what you're doing, go-tos can be very powerful and they can be a lot better than the alternative of nesting like 15 break statements or if loops or branching and stuff like that. It can be faster as well. It'll result in faster instructions. So that's what I'm saying about this. Like, delete this can be useful as well, but be careful about what you're doing. Because I wouldn't do it this way at all. Like, essentially what you need to do is, if you do that, is you potentially run something like a, I would almost add something to a queue that would be like, okay, the menu has changed. And that way we have the safe completion of this method. And then before we run update again or anything to do with this class again, we switch out the menu reference safely in the game class, and then we never run into this problem of, hey, we're modifying the existence of this class whilst we're in a method, in the middle of a method in the class that we're potentially deleting. Like, I hope you guys understand what the problem with that is. Again, in Java, it's okay because of reasons, right? Because the garbage collector is lazy. That's basically the reason. As I said, like, the only thing that holds a reference to this object is game.menu. And when we reassign game.menu to be about menu, that's it. Our references have been lost, which means we are in the to delete pile, because you can never run or reference anything in this class ever again, because we've lost the only remaining reference to this class. Yeah, it's like if you do, let's see. It's like if I was to do new main menu, right? Main menu only exists for this one line, assuming the constructor doesn't assign, something, okay? Like over here, main menu is lost. It's gone. It's already gone. You can't do anything with it unless I assign it to an instance, Yeah, if I do that, then it's contained within M. And then when M, for example, goes out of scope, which will be here, that's it. Nothing. Main menu, there's nothing. We can't retrieve it. We've lost it. We've literally lost it. It's like if you lose something. Yeah, it's gone. You can't find it. It's lost. So that's kind of what happens when we reassign the menu object. So it like in that sense, it's a little bit dodgy. And I said in this series, I would talk about programming practices and I would talk about what I did back then and how I would not do this stuff now. And this is a great example of something that might appear to be somewhat innocent. And if you logically think about it, yeah, it kind of makes sense. Sure. But actually, there's a little bit of a hidden kind of agenda behind this. Not really an agenda, more or less a mistake or an accident waiting to happen. But again, since Java happens to be, I don't know how Java's garbage collection works. It might recognize that, hey, I'm executing instructions inside a class that technically doesn't have any references. I guess I'll finish the execution of this method before I delete the object. It might do that. I don't know how Java works internally. All I'm saying is that that's not ideal. And if you try to write the same code in C++, and of course, assuming you handle memory properly, the proper handling of memory in C++ with this behavior would actually result in a crash or potentially undefined behavior. Hope you guys enjoyed that little rant by me, because I'm pretty much going to end the episode around here. If you want me to talk more about this kind of stuff, because I mean, I obviously like talking about, you know, core technology and stuff like that. And also about the internals of things and really getting low level into this stuff. So if you guys enjoy that and you want to hear more of that, just drop a comment saying I liked this episode and also hit the like button. And I'll know that I should do more of this stuff. But I mean, other than that, that's how menus work. It's really simple. We just reassign references. As to how the start button works when we actually start the game, again, it's horrific. We literally set game menu to null, which means that since it's null, we're no longer rendering or updating anything. So you can see over here, for example, where we have menu doesn't equal null. So we only render menu if it's not null. Obviously, if we set menu to null and we try to render it, it would crash with a null reference exception. Because we're trying to look up a pointer that is set to 0, which is not a valid memory address. And then over here as well in update, we do the same thing. So we set menu to null, which is good, which means we basically clear the screen. Now we've still got the problem of the fact that the level is set to be the menu level, which is over here. Yeah. Right? So the way that we deal with that is, because you can see we've set the menu to null, so what about the level? What happens to the level? Level plays true, whatever, don't care about that. In fact, what is that even used for? Because I'm actually a little bit scared of that code. Oh, that is horrific. So you can see that a lot of the way that I I do things is kind of by a system of polling, so to speak. So I set a value in memory. This is almost like what you would do if you were multi-threading something, because you can't directly call methods. You set a value, and the next time a method that is in a loop runs again, it reads the value and it's like, oh, okay, this value is now true, therefore I can execute this code once, because I'm then setting the value to false. And that's actually how the level selection works. So again, the problem we had was, okay, we've set the menu level, so how did this level ever get reassigned? Well, if you notice here, right, this is sneaky, because you would expect something like, you know, game.setLevel 2 or something like that, right, for biome 2. No, what it does is it sets the play menu, which is, which was a temporary menu. Let's see if we can bring that up. We should be able to, I'm assuming, because that's actually a bit of an Easter egg, because it's not actually contained in the game. Yeah, so we have a select biome, and you can see we can select something that we want to play. It doesn't really work properly, but that was a menu that I guess I made when they were going to be. So we have forest, snow, ocean, because this desert doesn't actually exist. And then random would be a random selection, I guess. But anyway, by doing something like that, it says play menu biome. I don't really care about that at all. The important thing of what it does though, yeah, so play menu.biome gets set to 2, or in other words, it used to be a random one between 0 and 2. So 0, 1, or 2, which would be either forest, ocean, or snow, or forest, snow, and ocean. I don't know what the, yeah, forest, snow, and ocean would have been the order. And that's it. So you're like, well, how does it actually start? Well, glad you asked, because what happens is we obviously return from this function because that's the end of the update function in the menu class. So where does that happen? Here, right? So what happens is we blah, 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 we update the level. Level is still the menu level at this point. And then what happens, you can see, is that it checks. It says, is play menu.biome set to 2? Well, in that case, obviously it just got set to 2 by our main menu. Play menu.biome set to 2 because we've hit play. So that's true. So it creates a new ocean level. It basically initializes the entire level and then sets the biome, this is this level thing, to -1. Right? So we set it to 2, we create the level, then we set it to -1, which means the next time, because this is in a loop, remember? Next time it comes in, oh, play menu biome is -1, so clearly it's not this. If we didn't set this last line of code, we keep creating the level over and over again. That would be bad. So you can see that's how it works. So instead of calling a method once, which would be the reasonable kind of logical way to do things, we have this code in a loop, and we basically continually check, we continually branch to see whether or not we should be in the state of, I need to create a level now. And that state lasts for one iteration, one frame. And then, of course, it sets like the menu biome to -1, which means the next time around, unless something sets it back to a value above 1, or a value that's either 0, 1, or 2, we will not be creating the level again. Okay, so that's how the menu system works. I'm pretty sure I answered everything you would ever want to know about menus in this sense. They're really simple. Read through the code if you don't understand it. If you still think that I haven't covered something about menus that you are itching to know and you can't figure it out on yourself, or you just think that I missed something crucial that I should mention, drop a comment below and I'll address it in the next video. Apart from that, next time I think we'll move on to the rest of the game logic, so how entities actually work, how the AI works, and I think what else is interesting? Maybe stuff like collision detection. I don't know. Leave your thoughts. Leave a request as to what you want to see next, because I don't mind. I'm doing this for you guys, obviously. And this series is all about explaining things that I wrote that you don't understand, and also obviously discussing like programming kind of techniques and practices as well. So if you enjoyed this video, please hit the like button. Follow me on Twitter. There'll be a link in the description below. And I'll see you guys next time with episode 7. Goodbye. Vroom.